I'm going to choose a value, say negative 3.5 here. So that's going to result in negative here, and a positive there. So when you multiply those signs all together, you get a positive. Here I'll choose 0. So that's going to leave me with a positive, and negative. And so when I multiply those together, I get a negative. And then I'll choose something greater than 2, which could be 3 or greater. And so all of these are going to be positive, which leaves me with a positive there. So therefore, and here's the final therefore, (2x cubed minus 3x squared minus 6x plus 1 is greater than x cubed minus 8x squared minus 4x plus 25. Those are the original functions f of x and g of x. When negative 4 is less than or equal to x, or sorry, less than x, less than negative 3, or x greater than 2. Okay, so now we look at the graphical solution, and these are the same two functions. Here's f of x, and here's g of x. And if we examine this very carefully, we want to see where f of x is greater than g of x, or above g of x. Well, f of x is this thick black line, and we see that here, for sure, f of x is greater than or above g of x, so we know that, and that's at x equals 2 there. So when x is greater than 2, just as we have here algebraically, we know that f of x is greater than g of x. And the other spot, which is very difficult to see here on the graph, I'm going to show you a magnified view of the graph in a second, we'll also see that f of x is greater than g of x when x is between negative 4 and negative 3. Well, here you can't really tell. This is negative 4 here, this is negative 3, and you can't really tell between those points of intersection what's going on there between those two graphs. So I've got a magnified view of the graph, and I'll just show this to you here. And if we look very, very carefully, we see that the point of intersection here of x equals negative 4, they intersect there, they intersect here, and just a tiny bit here you can see a little tiny daylight there where f of x is greater than or above g of x. So that shows, of course, in a magnified view of this graph, that f of x is indeed greater than g of x between negative 4 and negative 3. Okay, so now we have our last example, and what I'd like you to do is, now that you've seen this done a couple times, this is a little bit more challenging, but please pause the video and try to work through this example on your own from start to finish, and then I will come back and work that through in a couple minutes when you press play again. Okay, so now there's a couple ways that you could do this. You could either expand out the first two brackets, expand out the second two brackets and add them together. Or what you could do is you could just identify these two terms and factor out what's common. So I'm going to do it both ways just to show you how things work. So if I were to factor out x minus 3 from both terms, then I would get x plus 1 remaining, and I would also get x plus 2 remaining. Then I would simplify inside the brackets, and that would give me 2x plus 3. Then it would be a simple matter of finding the roots from that. Otherwise, what we could do is, if you want, multiply all these together. So we get x squared minus 2x minus 3 plus x squared minus x minus 6 greater than or equal to 0. Simplify and collect like terms, we'd have 2x squared minus 3x minus 9 is greater than or equal to 0. Then we could use sum and product, so we get 2x and x, 3 and 3, that would multiply together to give me 9. have to decide which one would use the negative sign, so I'm going to put the negative sign here. So the cross product part, negative 6x, multiply up there, we get 3x, and we add them together, there's the sum of the cross products, so we get negative 3x, which does match the middle term here. So these are the two factors, which we've already seen over here. Therefore, the roots are x equals negative 3/2 and 3. So then we set up our intervals. So x is less than negative 3/2, negative 3/2 less than x less than 3, and x greater than 3. I'll write down the factors, 2x plus 3 and x minus 3, and the sign of the products. So we'll get, if I choose, say, negative 2 here, this will give me negative, that'll give me negative, multiply them together, you get positive. In here, between negative 3/2 and 3, I'm going to use 0. So that gives me a positive here and a negative here, multiply those two together and we get a negative result. And we have x greater than 3, then that means we're going to have positive, and multiply those two together, and the product again will be positive. So therefore, 2x squared minus 3x minus 9, which is the product, the final function once we multiply all of those together, is greater than or equal to 0 when x is less than or equal to negative 3/2, or x is greater than or equal to 3. Otherwise, what we could say is x minus 3, x plus 1, plus x minus 3, x plus 2 is greater than or equal to 0 when x is less than or equal to negative 3/2, or x is greater than or equal to 3. Okay, so that would be the end of that example. Here's your fun for today. Do the first few questions at home, please, before you come into class. We'll do the rest at class. And the ones with asterisks, those are the ones that need a graphing calculator or some sort of graphing technology. You could do those at home using Desmos, or you could come into class and use your graphing calculators, or perhaps something online if you have a smartphone or a laptop, and you can do some graphing with those. And here's the group of review questions, because the test is going to be coming up very soon, as there are only 4 sections in this unit. Okay, thank you for your attention, and we'll see you in class.